It tells us about Ben and Sam, and they're working together to produce gizmos, and it tells us they can create some value based on the level of effort each person puts forth. So EB is Ben's effort, and ES is Sam's effort. Well, the first thing to know is EB, let's say it was 6. Well, that 6 doesn't mean anything by itself. That means that Ben's putting forth 6 units of effort. It doesn't really mean anything, it's kind of arbitrary, but we can compare that and say that 6 units of effort is not working as hard as 10 units of effort. So again, a lot of times we're going to use these arbitrary things, but they can mean something when you're comparing them. Just like in utility, 10 units of utility didn't mean anything by itself, but we did know 10 units of utility was happier than 5 units of utility. So the story here, like you may have kind of figured out from the title, is that in a group situation where you're working together and effort is what you're putting forth, some people have the tendency to free ride off the efforts of other people. They treat their gizmo production, in this case, non-cooperatively, and they maximize their individual surplus. So you're going to hear those words, you're going to link that with free riding. And anytime you see non-cooperative or maximize individual surplus, you're going to do the special case. And in this case, the special case would be dividing the value by 2 and having the cost, whatever the cost is, in this case it's effort, and in this case it's E squared for both guys, you're going to leave that by itself in the scenario when it's non-cooperative. When it's cooperative, you can solve it a couple different ways, so I'll talk about each of those. But it's pretty straightforward and pretty simple. Well, first, we want to write down what we know. Our total value function is this, and our cost of effort is this. So our total surplus, which is total value minus total cost, kind of like profit, we're just going to call it total surplus for these next few questions, is going to be total value minus total cost. So when we're treating gadget production cooperatively, we're going to maximize total surplus. So you can do this a couple different ways. Like I said, I'm going to do it from one person's point of view. So I'm not doing total surplus for Ben and Sam. I'm doing just total surplus for Ben. So I'm going to divide everything through by 2. Now, keep in mind, if you didn't divide everything through by 2, so if we just got rid of this 2 and just have this total value function here, and we did the derivative and all that good stuff, we would get the same answer for EB and for ES. So you may want to try that just to see what I'm talking about. But maximizing total surplus is the same thing as maximizing one person's total surplus, as far as you'll get the same EB and the same ES. Because you're dividing the whole thing through by 2, so you could kind of just get rid of that dividing by 2 or distribute it evenly to everything. So that's what we're going to do here. So we're going to simplify, and you see that the difference between this and not dividing everything through by 2 is not going to change the answer. So from here, we're going to take the derivative with respect to Ben's effort or Sam's effort. Well, one thing you want to notice is there's symmetry here. Both guys have the same cost of effort, and their value is symmetric. What I mean by their value being symmetric is there's a 10 in front of the EB, there's a 10 in front of the ES, those are the same, and the 0.5 is equal to the EB and the ES. So they create the same amount of value with their effort, the cost of their effort is the same, therefore they're going to be symmetric, therefore we can conclude that EB is going to equal ES. So we can make that substitution now. And we can solve for EB, and in this case, when we divide through by 0.75, we see that EB is equal to 6.66, and again, we already said that this is going to also equal ES. Well, this question just asks us what the difference was between Ben's effort when he did cooperate and when he treated gadget production non-cooperatively and maximized his individual surplus. So we found Ben's effort when he did cooperate, when he did maximize total surplus. Now let's find Ben's effort when he does this non-cooperatively. Well, total surplus for Ben is going to look like this now. We're going to divide just the value by 2, so he's splitting the gains evenly, but he's treating his cost on kind of a selfish level you want to think about. Now, he's maximizing his individual surplus, so he's treating the cost of his effort not evenly. He's not working as a team. When we do this, we see the difference mainly is we don't have that 0.5 EB squared and that 0.5 ES squared, and that's going to change the amount of effort that he puts forth. So we can take the derivative with respect to EB. Because of symmetry, again, we know that both guys in this scenario, or both guys are going to free ride, anticipating the other guy will free ride. So EB is going to equal ES, and we can make that substitution. And we solve through here and find that with free writing, EB is equal to 2.857. And in this question, again, they're just asking us the difference between the effort that Ben puts forth if he's free writing and if he's cooperating. So we're just going to find the difference of this, the difference between these two answers. Make sure you know whether it's a positive or negative sign. It all depends on how he asked the question. So just make sure you're thinking about that. Since this time we're minusing a bigger number, we're minusing a smaller number from a bigger number because it asks us the difference between when he cooperates and free writing, it's going to be a positive answer that you're going to enter. But make sure that you understand that he could have asked it a little differently and you could be finding a negative number.